Welcome to Yesterday, Today, Tomorrow. My name is Mariana Cordier, and I am your host. This week, we're going to be talking about the next frontier of the space race. And the guests I have with me today are Vedran Leshik. He's a professor and researcher from the University of Maryland. Christina Hartwell, also a professor and researcher from the University of Maryland. And Quan Cheng Hong, who's a PhD and is doing postdoctoral work at New Mexico State University. Thank you for joining me, everybody. And I wanted to start with Christine. When we talked before the show, you had mentioned that your work has been about asteroids, and I find that so fascinating. Can you tell us what you and NASA are doing about asteroids?
Yeah, so NASA has a number of space missions that are either in development or currently flying to explore asteroids, our neighbors in space. And we think that asteroids are remnants from the formation of the solar system. So NASA would like to study these bodies to understand how the solar system formed, and also to develop technologies to mitigate any threat that an asteroid might pose to the Earth. So if an asteroid is headed towards Earth, which NASA doesn't know of any that are currently headed towards Earth, but if one were, we want to have the technology so that we can change the orbit of that asteroid and make sure it doesn't impact Earth.
So that sounds almost like a movie. There was a movie, a few, I think. But what is it exactly, or how is it exactly that NASA and you as one of the researchers go about doing this?
So in order to change the orbit of an asteroid, there's a couple of different technologies that could be used. Right now, NASA is developing what's called the DART mission, and that's actually going to launch later this year in 2021. And the idea behind the DART mission is that you take a spacecraft and ram it into an asteroid and use that impact to try to change the asteroid's orbit. So that's one of the technologies that NASA is looking at right now. There's a lot of other missions to explore other characteristics of asteroids. So the OSIRIS-REx mission, for instance, that mission collected a sample from the asteroid. It went down, touched the surface of the asteroid, and it's bringing the sample back to Earth so scientists can study the chemical composition of the grains on the surface of the asteroid.
And what about, I speaking with you earlier, you had mentioned that some asteroids have their own moon?
Yeah, so asteroids, we actually think that many asteroids have a moon at one point during their life cycle. So asteroids, they're kind of a gravel pile in space that's held together by their own gravity and cohesion. And the idea is that these asteroids, their spin rate can increase, so they can spin faster and faster and faster around their main axis. And as they spin faster, eventually a chunk can fly off and form a moon. Eventually, the spin rate continues to increase, and that moon can actually be lost from the asteroid. So an asteroid might birth a moon and lose that moon multiple times during the life cycle of that body. So that's another hypothesis that we're testing with what's called the JANUS mission, which is a third NASA mission to explore asteroids.
So with so many different missions that NASA has going with regard to asteroids, to young people who may be watching the show and thinking about, NASA and a future in aerospace engineering, do you encourage them? Do you think that there is a lot of exciting opportunities for young people to study and have a career in this area?
Yeah, I think it's a great time to want to do space-related research. And it's not just aerospace engineering. We need electrical engineers, we need computer engineers, we need scientists, we need a lot of people from different disciplines to make these missions a reality. And there's not only NASA as an employer, but also there's many of these new space or commercial companies that are getting into the space commercialization or space exploration types of fields.
That's awesome. So we've talked about asteroids in some of the NASA programs, and now I want to talk to our other two guests that are going to talk about Mars. Is everyone ready to talk about Mars? So, Professor Vedran, thank you for being on the show. I really am excited to hear about your mission. Is it called InSight?
Yes, it is. The InSight
Tell me a
mission to
little bit about
Mars.
it.
Yeah, everyone's always ready to talk about Mars. It's an exciting planet, but it's actually the InSight mission to Mars, which is a NASA mission with a carrying the primary kind of scientific instrument being provided by the Europeans, which is a very, very sensitive seismometer. So this mission to Mars has deployed a seismometer which has been listening to the sounds of Mars and to small vibrations from waves that travel through Mars and from Marsquakes for the last 1,000 days. In fact, we're past day 1,000. Mars gave us the largest Marsquake so far on day 1,000, which is why that date kind of sticks in my mind. And since that mission has been there, we have been learning a lot about Marsquakes themselves, so detecting them for the first time and trying to understand what produces them, but also seeing inside Mars, trying to figure out how big its core is, what its mantle looks like, what the temperature inside Mars is, and various kind of scientific targets like that.
And why is that important to know I guess it's the geological, portion of our aspect of Mars? Why is that so important to us?
So, if you think about, let's think about the Earth for a second, because we're all more comfortable thinking about the Earth. If you look at where we live on Earth, it's really this very, very thin little veneer. It's thinner than the coat of paint on the planet. And the conditions that enable life on Earth really are controlled by much bigger processes that occur deep in our planet. Now, we know that in the past, Mars has water on the surface, and we want to understand what is that history of Mars? How did Mars form? How did it evolve? And what are the internal structures in Mars that maybe caused it to not be habitable the way that Earth is habitable now? A graduate student from our department who's done a lot of this work, Tron Chang, is actually on the line with us, and he can tell us more about what kinds of scientific questions we ask about the interior of Mars.
Definitely. That's a great segue. So why don't you tell us, what is it and why is it that it's so important?
Yes, sure. So Professor Lekic has given a really nice overview about InSight mission. So we know that earthquakes are happening every day on Earth, right? So the similar seismic events are also happening on Mars. So what we are doing is to use, the seismometer that has been deployed on the surface of Mars to record these seismic events. And what we can learn is because these seismic events, they have traveled through the interior of Mars. So they have been carrying rich information about the interior structure of Mars. So we can use these waves to study the interior structure of Mars. And we know that Mars could be simply divided into the crust, mantle, and the core. So some of the new results that has come out of the InSight Science team was to constrain the crust thickness of the Mars and also the size of the core in Mars. So yeah, so my contribution to this studies was to pull out the seismogram and look into the all kinds of the wiggles and find the specific wiggles that match the predicted arrival times of these seismic waves. So for example, I was using the core reflected waves. So these are the waves that travel down to the core mantle boundary in Mars and reflect back to the surface. So these waves have been recorded by InSight, and we could use this these seismic waves to constrain the size of the Martian core. And using this kind of measurements, we can understand, how Mars was formed and
Is
how.
it a lot like the Earth, or is it very different from the Earth?
Yeah, it's a good question. So the Martian core is surprisingly larger than we had expected before the mission. So which means that the core is less dense than we had previously expected. So there might be some lighter elements like sulfur or some other elements have lower densities in the Martian core. So that also has important implications for how the Martian core was formed.
And Professor Leszek, what about the fact that there's always the thought process of the public and maybe even the government of eventually being able to send humans to Mars and explore what benefits there are to Mars?
Yeah, so that's a great question. And in fact, from kind of the perspective of thinking about the safety of any future cities on Mars or whatever, we do have to understand the seismic environment there. That's not really the primary driver for what we do, but this the use of seismic techniques, so the use of seismometers to listen to small vibrations, but also other geophysical techniques like ground penetrating radar and magnetometers and gravimeters. This really is the basis for a lot of the way that people think about commercial exploitation of, and what's called in situ resource utilization on other planets and on the moon. So the kind of the big thing that's like coming up that some of our younger listeners might get excited about is the Artemis mission, which is our return to the moon. It has been about 50 years since we've been on the moon. It's kind of crazy to think that it's been that long.
We're back. We're going to go back.
We're not back yet. we're planning on coming back, right? The Artemis mission will put the first woman on the moon and will return to the moon in a much more kind of sustained way than had been done with Apollo. And I don't know how many people know, but the Apollo missions actually deployed a lunar seismic network. There were 4 and sometimes 5 seismic stations that were operating on the moon for many years, and they detected many moonquakes. They detected tens of thousands of very kind of strange, deep moonquakes that appeared to be at least related to tides. So the tidal flexing of the moon by the Earth. Just like the moon raises tides on Earth, the Earth raises tides on the moon. And that mission, came to an end. And now when we come back 50 years later, we come back with all new technology. And so we want to think about what kinds of geophysical techniques can we use to identify resources. So number one resource on the moon you want is water, right? Because you want to be able to drink it, but also break it up maybe into oxygen and hydrogen, which can be used as fuel, but also for breathing. And then to identify kind of other kinds of resources that can be mined. So for constructing future, I guess, bases on the moon, and for extracting materials that could be of economic benefit. So this also, yeah, that's kind of like where this is going in the coming decades.
I'm kind of scared to even contemplate the idea of mining anything out of the moon. Somehow in my mind, I'm picturing that cartoon where the moon splits apart and then we've got a bigger problem. But actually, it brings me back to another an issue that I know Christina's really up on, and that is space trash. And the fact that we've got a lot of things, parts and pieces circling around the Earth, and our precious satellites that we need them functioning and working without any damage. Tell us a little bit about that work.
Yeah, so or space junk or orbital debris. These are pieces of satellites, either that break off during normal operations or due to collisions between satellites. There have actually been 2 recorded collisions between satellites that make a huge cloud of debris or of this space junk. And the problem is that, orbital debris is moving very fast. So even very small pieces like millimeter scale pieces, when they impact a spacecraft, they can cause some real serious damage because they're moving at kilometers per second speeds. So the problem is that for the small debris, like a paint chip or a nut or a washer, they're too small to be detected from Earth, and yet they still pose a real hazard to spacecraft. So we're currently in my lab developing a new mechanism to detect small orbital debris by looking for the signature of that debris in the plasma around Earth, rather than looking for like an optical or radar signature, which is our traditional method of detecting and tracking orbital debris.
And what's the plan if you are able to track it? How are we then to clean it up?
Cleaning it up is not our problem. So there are many researchers that are working on technologies to clean up orbital debris. We are not specifically doing that, but even if you do develop a technology to clean up the orbital debris, you need a way to tell how well that technology is working. And so our method of detecting this small orbital debris would help you to say, like, yes, the environment's getting cleaner, or no, that technology really isn't working to remove this small debris from the environment.
And how is that debris different from fragments of, let's say, rocks, meteors, that kind of stuff? Is there a difference?
Yeah, so meteoroids or, natural objects that are coming into the Earth's environment, they are, probably less concentrated in the orbits that we use by satellites. So they're going to be kind of cruising in really fast, cutting through these orbits that we use with satellites. But the debris that is created by us, by humans exploring space, is going to be concentrated in these orbits that our spacecraft exist in, because that's where the debris is created. So it's just the frequency of impacts from human-made debris as opposed to natural debris like meteoroids is just going to be much higher. It's just a bigger risk because it's located where our satellites are located.
Why, and this is a question that I'm asking for all of us non-science people, why is the debris stuck in orbit? Why isn't it re-entering and burning up or things like that?
So it will re-enter eventually. Even very high above the surface of the Earth, there is some atmosphere. It's not a total vacuum until you get really far away from Earth. So there is some atmospheric drag, but it's just, these particles could be in orbit for hundreds of years. And as we have more and more spacecraft in orbit around Earth, we're creating more and more debris. So you might have military applications where one nation might shoot down another nation's satellite. This has been discussed. It's never actually been done, but a test has been done. So we know it is possible for that to happen. So that would create a debris environment. Or you could have an inadvertent problem like a CubeSat or some small satellite launched by a commercial organization happens to get into the wrong orbit and accidentally hits another spacecraft. And that would also create debris. So these are some of the risks that we're concerned about.
And with regard to the future of NASA programs, how do you guys see this next frontier of space and programs and missions? Professor Lejcik?
Yeah, I guess the next kind of round of space exploration will maybe be a little bit different than what we've used to. What we're used to is NASA preparing these kind of awe-inspiring missions, sometimes in collaboration with other nations. But I think, especially with the Artemis program, which is incorporating something called the Commercial Lunar Payload Service, they're really thinking about engaging the private sector and kind of commercial companies, what I think Christina referred to as new space, I don't know if that was the right term, or if my memory is right. But yeah, so essentially now there are many companies that are competing to access space. Low Earth orbit, is a very useful place if you want to provide, for example, internet, the way that Skylink or SpaceX and wants to do. But even going to the moon and potentially to the asteroids, some of the nearer asteroids, there are private companies that want to do this. And so NASA is trying to kind of both encourage them, but also get some scientific return by placing scientific instruments on these commercial landers. And in fact, one of the missions that we're excited about as seismologists is called the FarSide Seismic Suite. And this is a mission that's run out of JPL, and they will use this commercial lunar payload service to get a seismometer, a very similar one to the one on Mars, but actually only one component instead of three, to a crater on the far side of the moon called Schrodinger crater. And the reason for this is that the previous seismometers we had on the moon were where the astronauts landed in the Apollo days, which are all on the near side of the moon. So we don't really know what the seismic environment is on the far side, and we don't really understand the kind of structure on the far side as well as we do on the near side.
That's really exciting that you're seeing a little bit of a marriage between the private and government agencies, and perhaps this is the way to go in the future.
Yeah, I mean, certainly some of the, if you compare the development rate of something like Falcon Heavy or the Starship program to something like this SLS, which NASA is doing with their traditional partners, I mean, it's at least order of magnitude faster in terms of development. SLS has not yet had successful launch. So
what is the SLS?
This, I think it's like Space Launch Service. What is it? System space. It's essentially using the some of the technology that was developed for the space shuttle and making a rocket that's of comparable capability to the Saturn V, which is the rocket that sent us to the moon back in the 60s and 70s. And SpaceX, which is a private company, has been doing something similar with what's called Starship. And that rocket seems to be at least, they started much further back, but they're catching up much faster than I would have expected even like a year ago. So
that's very exciting for scientists because it gives you an opportunity to get your instruments on these delivery systems faster than if you were just relying on NASA.
Yeah, sometimes when you hear the cost of a mission, you're like, whoa, hundreds of millions of dollars. But the launch itself was sometimes hundreds of millions of dollars if you just forget about the spacecraft. So, yeah.
And so why is it exciting to be back at the moon?
It's an interesting question. Actually, Apollo told us some things about the moon, but the moon is actually kind of, it's interesting, right? The moon formed, we think, from the Earth, right? There was a massive impact of a Mars-sized impactor, which then spun off the moon. So in order for us to ever really truly understand the history of our own planet, we have to understand the history of the moon. It's important for us to understand what resources are available on the moon, because it is much easier to use the moon as a base than it is to use, to get all the way to Mars. And we only explored 4 little dots on the moon really in any significant detail during the Apollo missions. And so even the idea of having a permanent presence there and more extensive exploration, particularly of the polar regions, I think is very exciting, at least for me.
No, that's fantastic. Are there, well, I'm going to give Christine the last word. What is the last word you would like the audience to have as a takeaway with regard to NASA and all these projects?
I guess the takeaway message that I would have is that NASA is doing a lot of really interesting and exciting science. It might not be what we traditionally look at, it's not the space shuttle, but there's, NASA is still very active. There are a lot of vehicles exploring Mars, a lot of vehicles exploring asteroids, and there are a lot of players other than NASA involved as well. So we have other countries that are doing some great work and building up their capabilities. And then we have commercial entities as well that are also, going to be working with NASA to push our science and exploration forward. So I think it's just, it's a very active time, even though we don't have the traditional space shuttle sort of launch system going on.
And that raises the issue of funding, that it's important that NASA continue to be funded.
Yeah, so NASA actually gets less than 1 penny per per dollar that is spent in taxes, right? The NASA budget is less than 1% of the total federal budget. So if you think about what NASA gets done for the tax dollars that are spent, it's pretty incredible. I mean, the Mars Science Lander or the Mars Curiosity Lander, I think that cost each, taxpayer like $8. Right, and we have a vehicle that explores the moon, explores Mars. I'm not sure if those are the exact numbers, but the point is that for less than the price of a movie ticket, we have a spacecraft that is exploring the surface of Mars, and that's pretty incredible and shows like what we can do as a nation to explore the universe, which we are very fortunate to be in the position to do both technologically and economically.
That's a really good point, and one that I want the audience to really consider when you're thinking about supporting NASA and our scientists, because it's our future. You just don't know what you're going to find. Well, we have run out of time. I would like to thank my guests for participating on this show. Y'all were awesome. And to the audience for watching, you can catch us on YouTube. We're also on Channel 21, and you can also see us on Tuesdays and Sundays. Until next time, goodbye.